Okay, so we're going to talk about section 2.2, which is an extension of 2.1. We're going to talk some more about functions and their graphs and information that we can get from a function or a graph. So the first thing that we're going to talk about is increasing, decreasing, and constant. And so for an increasing function, what happens here is we consider a function increasing on an interval, okay? Now, it specifies here that f of x1 is less than f of x2 whenever x1 is less than x2. Now, what you need to understand here is when it says the word whenever, that means we've already selected x1 less than x2. So we're making that occur first. And this occurs for any x1 and x2 in the interval. So we're going to take a look and I'm going to show you a picture of how this is set up. Okay, so we've got a graph picture here. Increasing, it's up a hill. Okay, now the concept here is we're making a bubble happen down here. This is that interval I that it was talking about, and you're picking it so that x1 happens sometime before x2, and when you go up here to the graph, here is f of x1 and here is f of x2. So f of x1 is lower in value than f of x2. And this happens for any f1 or x1 and x2 that are inside of that interval, okay? Now, we then talk about decreasing, okay? So with decreasing, it is same thing. We got an open interval. At this time, f of x1 is greater than, okay? And this is the only symbol difference right here is this greater than symbol that's different than the increasing one, okay? So we have f of x2 whenever x1 is less than x2. So we're still, again, picking that x1 is going to be less than x2 in that interval. So we're actually picking that x interval first and then making sure that we see what happens. So again, a pretty picture for this. Okay, so we've got our pretty picture, and I'm showing these in quadrant 1, but it can be anywhere. So decrease is going to look like it's going down a hill. So again, we pick an interval down here, and we're going to pick an x1 and then an x2, again, making sure that these happen kind of like you're reading from right to left. And then when we go up and put these onto function, here is f of x1. Here is f of x2. So now we've got that these y values are decreasing or coming down. Now, it doesn't specify, okay? It just says in any open interval. Generally, we try to make the intervals go as large as they can when we're stating these increasing, decreasing, or as we'll see here in just a second, the constant ones, okay? So then we've got constant. Now, constant says, that it is f of x1 equals f of x2 for any x1 and x2 and I. Notice here it doesn't specify that x1 has to happen first before x2 because they should all be going to the same answer, okay? So again, pretty picture for this. Constant function is going to look like a straight line. Again, here's our interval. And I intentionally do this one. I'm going to pick it so that x1 doesn't happen first because it doesn't have to. The concept here is if I go up here, that's f of x2. That's f of x1, so the same values. Now, what they're going to ask about is on a function, they're going to give us a function graph, and they're going to ask when is it increasing, decreasing, and constant, okay? When is going to be, we're going to talk about the x's. So from this x to that x. So from -2 to 7, it was going up a hill. From -3 to -2, it was going down a hill, whatever. It does not matter how high it gets on an increasing or how low it gets on a decreasing, just that we are increasing or decreasing, okay? So I'm going to pull an example here. I'm going to transfer it over to our whiteboard over here so that you can see it, okay? So it asks us to state when are we increasing, decreasing, and constant. So I'm going to get this transferred real quick. Okay, so here we go. Okay, so we've got a graph picture that looks like this. Sorry for the glare. Now, it wants to know when we're increasing, decreasing, and constant. So increasing is going to be when we're going up a hill. So we start going up a hill here. Now, I'm going to take some assumption here and say that this is a function that keeps going either direction. So again, we're worried about the x's. So this thing is constantly going up a hill from here. So we've got increasing. We're going to start at negative infinity. We're actually talking all the way back over here to the left, all the way up to this hilltop, which is right here at -1. It's like think of it almost like a timeline in history, okay, type of thing. I don't care how big the Roman Empire got. I just care when the Roman Empire was growing, okay? Now, then we've got a downhill chunk. So we've got a decreasing piece, okay? That decreasing piece starts at -1 and goes until the bottom of the hill, okay? So it goes to +1. And then we've got another chunk that's going up a hill. So let me erase here real quick because I need some notation. So decreasing was -1 to 1. And then to say that there's that other piece, we're going to use that union symbol, like what we saw in the interval stuff. And this is from 1, and it just keeps going out the rest of the way. So then we've got from 1 to infinity. Notice that I'm never specifying how high it got, because that part's not of concern for us. In the next thing, we'll talk about maxes and mins, which is going to rely on how high it gets or how low it gets. But as far as interest, now this one did not have constant. Now, with our definitions, it does say open intervals, which means everything down here in the intervals should have parentheses around it. Occasionally, you will see some bracketing done on the numbers. Different textbooks or different versions will use that. I go off of the definition of open intervals because in my mind, I think of it like a roller coaster. I'm not going up the hill. I'm not going down the hill, though, when I'm at the very top of the hill. I haven't made that transition from one movement to the next, but I'm not sitting flat up there long enough to be able to say that I'm doing anything. So I call it open intervals on all of them.